the what. So if we're talking about taking an antibiotic and using it to produce pills or something on a large scale, or versus just talking about, say, the changing of an antibiotic molecule to make it a little bit different, to react different ways. So there's a difference between what we would use large scale versus what we would use just to find out some more information. And that's kind of what this question and the next one are looking for. Using the skills in chemistry that we have to test, say, a water sample. Chesterland water's got a lot of iron in it. That's, you know, it comes running out of the sinks yellow, usually on Mondays. So maybe we want to do a test with a particular device that lets us measure ion concentration. That would be using technology in science. Okay, and number 12 says the definition of applied research. Okay, so applied research versus pure research. Pure research is just doing experiments and tests to find out something new. And applied research is taking the information we have and using it to help us in our everyday lives. So, chemists discovered acetylsalicylic acid, and Bayer used it to produce aspirin tablets and distribute them worldwide. Okay, that would be applied research. A chemist, who I should know the name of, but I don't off the top of my head, developed the compound for nylon fiber, and then we use that large scale to make, first they used it to make parachutes during World War II, and then we've got nylon in, you know, half of the clothing we wear, etc. And that would be applied research. Alrighty, number 13 is asking you to describe or give the characteristics of basic research. And this is one of those questions that says, and I quote, which statement is not true about basic research? Which statement is not true about basic research? And what I see people doing on these questions is they look at the answers, they're like, oh yeah, that's basic research, that one's basic research. They read the first thing and it's like, yeah, that's basic research, and they pick that answer. Instead of paying attention to the fact that the question is saying, which of these is not basic research? So this is very much tied to the question before it on applied research, where now you're, in this question, you're looking for the one that's an example of applied research and not just gathering information to find out something new.
So basic research is just like doing the experiment and taking the information from it?
Right. And using that to identify a new substance or synthesize something or just learn what's there. Okay. Applied research takes it to everyday life where lots of people can use it. All right, am I going too fast for you or no?
Okay.
Yes.
Can you go over 11 again?
Yes. An example of technology versus just science. Using the computer to model the effects or the pattern for a disease outbreak across a country.
Would be technology?
Would be technology. Because we're using, not that it has to be a computer, but we're using tools that help us analyze something as opposed to just doing pure research. Okay. Yeah.
Would using like an electronic balance be an example?
Yes. Lily?
What's the difference between applied research and technological development?
Well, the way I described it at first, I think, was misleading because they're closely tied. Technological development is taking these advanced tools, advanced measurement devices, advanced analytical testing devices, and so on, and use that to do our research in the science lab. Okay, whether it's pure research or applied research, technology affects both. Okay, is that better? All right. 14, you need to know what matter is and be able to give some examples. This question is one of those all of the following except questions. So again, you're looking at the 4 answer choices very carefully and thinking about what matter is and finding the one that isn't. So if I said, well, let's think about the iron and sulfur lab we did today. We had iron, we had hydrochloric acid, we had the glowing red from the heat, we had the slug afterwards. Which one of those is not matter? No?
C.
C, right? The fact that it was glowing, that's energy. Okay? So think about whether or not the example given is a substance or whether it's a form of energy. Energy is not matter. They're closely related, but it's not matter. 15, examples of physical changes or properties. Okay? This will be, the answer choices will be a series of common everyday things, and you have to figure out which one is physical versus chemical. So, an egg frying, or silver tarnishing, or frosting a birthday cake, or an apple rotting. Which one of those is a physical change? Mark? Frosting a birthday cake. Okay, because we didn't change the fact that it was frosting or cake. But when an apple rots, it decomposes into various other chemicals. When silver tarnishes, it reacts with actually the hydrogen sulfide gas that we just produced today. To make a different chemical compound, and honestly, I forget my other examples. All right, 16 examples of chemical properties of matter. Remember, chemical properties, we have a long list of physical properties, but not so much on the chemical side. Chemical properties always have something to do with how a substance reacts. Either the fact that it doesn't react with a certain thing, or the fact that it reacts or how it reacts. So when you put the sulfur in the hydrochloric acid, what did you notice? Okay. I hope they don't start swearing on my camera. When you put the sulfur in the hydrochloric acid in lab today, what did you see? What happened? It floated. Was there bubbles? Was there a color change? Was there heat or light given off? No. No. So sulfur and hydrochloric acid did not react with each other. And that is actually a chemical property of both sulfur and hydrochloric acid. Now what happened when you put the iron in the hydrochloric acid?
Got hot.
It got hot, and it fizzed, and it probably smelled a little bit. Okay, so we had gas given off, we had heat given off, and we had a new odor. So there was a chemical reaction between hydrochloric acid and iron. Okay, that would be the fact that iron reacts with hydrochloric acid is a chemical property of iron. The fact that sulfur does not react with hydrochloric acid is a chemical property of sulfur. Yep.
So if something's magnetic, would that be chemical then, or would that be physical?
Okay, I'm going to step away from the camera for a second.